you a student, mentor, or parent that loves robotics? Then you're in the right place. Up-to-date info on all things robotics. This is the RoboZone Podcast with your host, Pete Ekman. The RoboZone Podcast is brought to you by Kettering University. It's a Kettering-built world.
Hello and welcome to the 46th episode of the RoboZone Podcast. This podcast is for Tuesday, January 30th. In this episode, we get some updates. We talk to some mentors. So let's get started with our first segment.
Now it's time for the first update.
Team update number 6 came out since the last RoboZone podcast. In this update, section 6 was updated, specifically under C07, and in that section, under A, it says contacting an opponent during the endgame while in your platform zone and attempting to climb, and B, placing a power cube on the scale plate, resulting in the opposite plate moving upwards into an opponent robot such that the opponent robot ends up violating G25. Under section 7.3, robot-to-robot interaction, clarification for yellow card was provided, so I encourage everyone to read that update. And finally, under section 7.4, in field interaction, under G25, plates are moved by power cubes, not robots, except via the weight of placed power cubes. Robots may not directly or transversely cause or movement or prevention of movement of plates because of momentary robot action resulting in the minimum plate displacement is not a violation of the rule. A robot forced to affect the position of a plate because of contact by an opponent robot, either directly, transitively through a power cube or other robot. There are some clarifications underneath the violation section in this section, so I encourage every team to go out there and read team update number 6.
The RoboZone Podcast is brought to you by AndyMark.com, your robot parts experts.
And now, let's talk electrical design and lessons learned.
John, please introduce
Hello.
yourself.
Yeah, I'm John Uren. I'm coach of Team 1684, the Chimeras.
We have Jeremy.
Hi, I'm Jeremy. I'm head mentor for Team Hollywood 7211.
We have Scott Stapp.
Hey, this is Scott Stapp, Team FridgeBot 5084 out of Corona, Michigan.
And bringing up the rear is Andrew.
Andrew Spees here from F.I.R.S.T. Team 5114, the Titanium Tigers, programming mentor /
And with that, we're going to start this conversation off by talking about electrical design. John, I'm going to start off with you. How did your team go about their electrical design this year? And this can encompass anything from motor controllers to the joysticks that you're using. Yeah, they're all intertwined. So please tell us a little bit about what the Chimeras are doing this year.
So the last couple of years, we've been using the Xbox controllers for driving and operating the robot, and we really like that. So we're continuing doing that. Last year, we used strictly Talons using CAN, which we liked a lot. So this year, we're going to use Talons and SPXs, I believe they're called. That's like the new CAN Victor. From Vex Pro. They're like $50 cheaper, so they save a little bit of money, or $40 cheaper. So it's a little bit easier just to, it's good to buy for both robot. Like we're trying to build 2 robots, so when we buy for both of them, it's nice not having to spend a fortune in just motor controllers if they're a little bit cheaper. So, and they do the same things. So, but yeah, mostly just we're doing the same system, I guess. We're using more pneumatics this year than we did last year, so that's a little concerning having a second subsystem you have to monitor, but as long as you're doing it, you're fine.
And Jeremy, how you're a fellow rookie mentor like myself, even though we've had previous experience. So tell us about how you're going along your electrical design this year.
Yeah, so we decided this year to take our electrical panel and kind of elevate it in our chassis about 2 inches and invert it so the electrical panel is down. And we're coming across some bumps in the road.
Can you elaborate on what the bumps in the road are?
Yeah, we actually just took our robot over to the Engine Nerds, and they were nice enough to let us run it on their platform. We're doing a wide bot, right? So the wheels kind of are not touching the top of the platform as we're getting closer and closer to the platform. And the electrical is getting scraped along the platform, redesigning, reiterating, coming out with a new plan.
Okay, and we'll dig a little bit more into that, Jeremy, in a second. So, Scott, tell us how the fridge bots are approaching, or what's your focus for your electrical design this year?
Well, this year we started out with a complete rolling base right off the bat. We already had it up and going. We're putting our prototype pieces onto the frame so that we're able to figure out which electrical components we need to add. Once we work out all the bugs on sensors and motor controllers and position sensors and whatnot, then we're going to package it onto the actual robot. But our focus is going to be on the actual functionality of the robot, the things it has to do, and then package the electronics around it. But we've started out with a running moving drivetrain already. We're just adding on to it.
So how are you facing the electrical board, Scott? Are you facing it up, to the front, to the rear of the bot, towards the bottom like Jeremy approached his first round? How are you guys going to orientate that?
We haven't even gotten to that point yet. We're not too worried about it. We've had some amazing innovations in the past years, and we know that we're going to be able to fit it no matter how we build everything else. Basically, our approach is going to be pick the functions we want to focus on and then package everything else around that so it all fits.
Okay. And Andrew, how is your new team approaching their electrical design this year? Do you know?
I would say we're really getting the prototyping and really focusing in and iterating on our different mechanisms is where we're at right now. There is thoughts and sketches going around where we're mounting things, but as for like exactly where they're going, it's still in kind of a rudimentary starting phase. I would say that we're sticking with the Talons this year due to a generous sponsorship from CTRE. We've got some Talons. We're still getting used to. We want to really get a good handle on using the advanced functions of the Talons where we haven't been able to in the past to kind of ramp up our autonomous game. So getting a really good handle on how all the Talon functions work when it comes to avoiding brownout on your motors, and also, playing around with the motion magic in your autonomous mode so that you're giving a nice smooth takeoff and stop, because we want to really make sure that we are attacking both the scale and the switch in autonomous. So really having a good control over our robot in autonomous is kind of a focus we're kind of putting on this year.
Okay. So let's expand on this a little bit further. So, John, how many motor controllers and motors are, because they're associated with each other, how many motors are you running on your robot this year?
I think I'm at 10 right now. We're using a lot of pneumatics, so that substituted a couple pivots where we normally probably would have used a motor. So we're probably sitting at about 10, and maybe 11.
Tell us a little bit more what your team is going to use pneumatics for.
So our manipulator is pretty unique in the way we're doing our arm relative to the manipulator. We didn't want to have two motorized pivot points, if that makes sense. So like the top of the arm flips up, and then we have our manipulator on the front of the arm. So we ended up using pneumatics there, just kind of pulling that in. And then our climber, we have like 3 different versions going, and one of them uses pneumatics kind of flip the hook up to grab onto the bar. So we're definitely taking advantages of. The thing I like about pneumatics is the speed, just being able to reach out real fast and pull back. So that was one of the reasons why we put on our manipulator. So
nice, and I'm can't wait to see what that design looks like at some point. But we do follow. Oh, I started following you on your vlog, so
cool.
We'll put that back into the show notes for this week. So Jeremy, let's backtrack. You're a rookie like me. So what are you guys focusing on? Well, let's start with that question. What is your team focusing on as far as the game's concerned?
We're taking the approach that we think a lot of the low-end resource teams are going to strive in the vault area. And so we're trying to, I guess, be the best vault robot that we can be. We think that there's different areas of the game that teams are great at. Some, like with high level resources, may go for like the scale kind of climbing or something like that. And then you have lower end teams that probably would take advantage of like the vault. So we're saying that we probably have lower end resources, and we're just going to try to be the best vault bot we can be.
And going along with that line, because I know you're a rookie like myself, and we have the kit of parts, which is primarily a lot of the stuff that we're going to use, correct?
Yeah. I'm actually starting to look at my bill of materials sheet, and I think a lot of it's the kit of parts. So I think my job this year is going to be easy.
So going along that line then, are you using a mixture of motor controllers such as I am?
Yeah, we actually upgraded our drivetrain, and so we have, I think, about 10. Right now we have 10 on our robot, and we might add one more depending on if we need it or not. But we got Talons, SPXs, and Sparks.
Right, and I know that John brought up the Victor. John, what was it? A Victor SR?
SPX. I'm gonna double check that real quick, but I'm pretty sure it's the Victor SPX.
Yeah, I think I ordered a couple of those from the robot space for my team, and they were a huge savings compared to a regular Talon. So
217-9191.
Thanks, Scott. I knew Scott would know it. But it does save a lot of money for a rookie team. I mean, I can buy 2 of those Victors for what I'd buy a Talon for, so it kind of helps a little bit in the budget area. So, Scott, are you running a mixture of, or I think you said you're using Talons. Are you using any other? Are you using any Spark? How many motors are you going to run on your robot that you know thus far?
We're running 4 in the drivetrain. We're running a 775 motor and the fabulous VEX Versaplanetary set for our lift. We've got another pair of 775s and Versaplanetaries running our intake mechanism. After that, it's a lot of, what do I want to say, passive systems where it's basically belts and pulleys and surgical tubing making all the magic happen. So we're actually able to keep our weight and our number of motors down. We're trying to make the robot as aligned as possible, making sure all the wheels are straight and parallel to each other so that we have the rolling resistance, maximize our battery life out on the field. I think this is going to be a game where quick is key, so we need to be able to make sure it stays light and fast. But you also got to be concerned about the top heaviness because these are going to be tall robots.
Andrew, how many motors, since you're the programming lead, right, for your team, how many motors are you guys going to have on that robot?
Well, I was just counting in my head. I know there's going to be 10. There may be an 11th one depending on, we plan on using our lift to hang with. So it'll depend on if we need to put anything else out there for that hang. So we're looking at about 10.
And you guys are going to use, you said you had a generous sponsor, which I'm jealous, and I'm sure Jeremy is too, or any mentor for that matter, that you can afford to use all Talons on it, right? So that's a pretty big sponsorship right there.
Oh, yeah.
Nice and sweet. Love it. You didn't go any further into that. It's like, yeah, so, yeah. All right. So the last question I have as far as electrical design is John, what advice can you give as a experienced mentor? What advice can you give to a rookie team that's looking at this daunting task of putting all these motors and having all our ideas? Give us some pieces of gold as far as information or recommendations that you can give us.
I would say don't be afraid to start off small, right? So start with your drivetrain and then give it to the programmers, or some teams, like the person who builds the drivetrain is the programmers, right? Let them play with it, understand it, get some time with it, move it around, and then, all right, then put the 2 next motors on, test them individually, give back to the programmers. Just making sure, actually today, pretty much our whole prototype was just wrapped up in programming. So like it was really important for them to just kind of understand the movements of the arm and the weight of the arm and all this kind of stuff. So a lot of people worked off bot, right, off in the corner on different parts and pieces. But I would say for new teams, just making sure that they understand the programming, because there's so many times when somebody says, hey, can you make your programming go a little bit slower or change your drivetrain or something like that? And they're like, if you help us. So I think it's really good advice for a new team to spend time understanding how the electrical works and then also how to program it to make sure that it's working effectively for strategy to strategy between matches.
And how about as far as like using the right coloring for the wiring? And inspection has a lot to do with it for electrical, which I'm afraid of. But
making sure you don't plug your radio in backwards and making sure you use the right gauge wire. All that's pretty much outlined in the rule book. So just kind of bringing that up and double check it. Even some of my students who've been on the team for a couple years, I'm like, hey, what gauge wire do you use on this? And they're like, and then all of a sudden they'll pull their phones out and look it up. So having that as a quick reference is always good too.
And what is the rule for the gauge wire? Do you know it off the top of your head? I know I'm putting you on point, but
I would actually have to double check it because I'm always scared. I always double check it for whatever reason. It's one of those things in like volatile memory. It's gone instantly, and then I just pull it back up in the rule book every time I look at it. So
he's pulling his phone out.
Yeah.
Yeah, I'm totally not typing on my computer right now.
Yeah, I know. All right. Well, we'll move on to Scott. Scott?
Well, I would say the things that you find in the normal world don't necessarily apply to FIRST robots. A lot of people will tell you the first thing you have to do is solder your wires. You don't want to do that on a FIRST robot. You want the mechanisms that are inside your fuse block and on your motor controllers to be able to bite into the wires. And if you make them a solid, hard mass like soldering does, you're going to shake them loose. You're going to have connection issues. So you want to leave them loose and pliable so that the things in the fuse block can grip real tightly onto your wires. You also want to make sure you label everything. Every little wire that goes from one place to another, you want to label where that goes so that if something falls out or the programmers want to know where something goes, you can easily identify those wires.
And just a follow-up question real quick, Scott, what about putting, I know you can find them online, like a 3D print end cap for your motor to protect the wires from being hit. Do you suggest those?
Oh, yeah. Anything that you can do to protect those wires from getting bent over or busted or fall out. We've had all of that happen out on the field. In fact,
the robot space is selling a new product that helps with that.
Yes, it is.
Interesting.
Our very first robot, the first year we ever were on the field, we did the old solder wire thing, and we all of a sudden had a checklist. And that's another thing I would recommend, even for electrical, have a checklist. Go through and check your connectors to make sure they are solid and secure. Nothing's worse than getting halfway through a match only to find out your wires weren't tight.
Andrew, give us some pieces of advice for a rookie team when it comes to wiring electrical design.
All right, so first I'd like to give some really good advice, actually, for overall for your robot. One thing that I would really highly recommend rookie teams pay very close attention to are some of the minimum robot concept matches that they have that you can find online, and watch the EveryBot. It's a very simple design that they did, that they were able to score very quickly and be very effective at a very minimal robot design. So I would pay very close attention to some of the ideas that are there in those matches. And if you haven't gone and watched those, I highly recommend going and doing so. That's the first thing. I guess for your electrical, I mean, the number one thing in the world that you have to do is label everything. Like, I can't express enough how many rookie teams that I've seen in the past where you go over there to help them and you feel like you need to rewire their entire robot because they did not label their wires so that they know where things are going. even if you just color code them with similar tape, so that you know at one end it's got red tape and the other end has red tape, you know that it's going to where it's going on the robot, into the power distribution board, into the Robo reel. So there's nothing I can say enough about at least color coding your wires with some electrical tape. I guess that would be probably the number one thing. If you don't do that, you're going to annoy me when I come over to try to help you with your robot. But not that I won't come help you. I'll still help you. I'll still do everything I can. But that is one thing that I would really pay attention to. It's a very important thing for students to learn, right? To make sure that they label their wires.
So, John, the next question I have for you is, let's talk about lessons learned. What have you learned so far from when you were at Kickoff or wherever your team watched Kickoff? Mm-hmm. What have you learned from then to now that's helped your team?
I would say one of the really interesting things is that the fact that if you get a solid first layer of cubes up in the scale and the scale is tipped towards your side, that those cubes would, if you try to side load the scale, they slip right out. Like if you kind of just chuck them up there, if you set them gently, right, then they won't slide around. But our team has been really shocked to learn how much those cubes slide around on top of each other up there. I thought they would nest a lot better. I thought they'd kind of fall in between each other. But that's been kind of like the biggest thing for the last week or so we've been talking about is how shocked we are that you have to have like almost a gentle touch, or you have to really bury it in the back to make sure that those cubes don't slide out. So
those teams that are focused, the more that are going to lift and put stuff up there are going to have to put some type of shielding on their bot because there may be a cube coming down and you don't want to hit your electrical board to. Yeah,
that's also that's a really good point you made there. Is if let's say hypothetically I just chuck it up there and somebody's to the right of it and it slides off on them, they got to be prepared to take that hit. So yeah, kind of being cautious of that would be probably some pretty good advice too.
And when it comes to chucking it up there, let's see if you know this rule. What is the rule with chucking it up onto the scale? Where do you have to be?
You got to be in the null zone. Yep.
Is there any penalty for injuring another robot because you chucked one up there?
I think at that point it's about intention. So I'm not 100% sure on that. I don't remember seeing anything that sticks out. I could be wrong, but typically it's one of those accidental things too, where I don't see too many people getting upset that if you slide one in there and then it slides back out the other side and lands on somebody. I don't know if that's necessarily your fault if something breaks. I don't know what you'd have on your robot that could be that. Like I hope nobody's going to put the Robo Rio at the top of the robot, like exposed and ready to get hit. So, and in 2012, our main breaker actually, there's some good electrical advice. If you have to put a main breaker on your robot, make sure you put it in a way that a piece like a cube or another robot can't hit it, because in 2012 the bridge tipped and it turned our main breaker off and our robot died because it powered it off. So we came up with like a little shield that we put around it with there was a hole that you could reach in and poke it, but it's this really weird thing where you got to be careful that you make it accessible, but don't make it where it's so accessible that a robot or a cube could turn it off. So be very conscious of your main breaker, because if you put that way deep down inside your robot, the inspectors at your first comp will make you move that into a more exposed area.
I'm hoping that we get a inspector on one of the podcasts before the season starts so we can get some advice from them. In fact, I'm trying to get them on for next week. So there's a couple that awesome. I interviewed last year, and I'm hoping to get them back on this year so that we can get some of that advice. Jeremy, what have you learned as a rookie mentor this year, guiding a brand new team? What have you learned since Kickoff, where we're at together? We were at the same place together in Kickoff. What have you learned between then and now?
Well, just taking lessons learned from this podcast. I need to find a new home for my main breaker. And but the main thing is to fail fast. We got to figure out, like, write anything you make on your robot it's not going to work the first time. And if you do, you're probably going to end up making lots of money. Most times it doesn't work the right time, the first time. So fail fast. From hearing from a lot of people, I've been listening to John's vlogs, and he's been talking about like the bumps and the platform. And I think I'm going to take it one step further. And I think CG is going to be a huge factor in the people going for the scale, or the people that have tall bots that can get real high. We might see a lot of robots on their back.
We hope not. As a guy that's going to have a tall robot, I do not want to. In fact, we were talking about that yesterday, the center of gravity, where the center of gravity is on the robot, because you can't, if you have a climbing mechanism that weighs 16 pounds on the back of the bot, which ours almost is, you don't want to put the battery back there too, because you're just going to end up on your back. Anything else that you've learned besides what you learned today and you've already expressed by, going and practicing on a platform?
Yeah, I think that if you're around an area with someone that has a field, or you're able to make the field, I think we kind of, with low resources, decided that there's enough people in the area that we can kind of reach out to them and use their field components, and just test it, like just get it up and running, getting it tested, and getting it. You're gonna have issues. You just can't avoid them, and the sooner you can get it to a field practice. Now we figured out that we're gonna have to work around the corner of the platform one way or another.
Good. So Scott, what have you learned? And you're an experienced mentor. What have you learned since kickoff to now?
The height of the robots is definitely going to be an issue. There are ways to work around it, but I think the main thing is going to be I got to get my driver some practice, especially with the mechanism up and in the full up position. So that's going to be touchy, especially with I got a brand new driver this year. So I learn stuff every single day. So I'm not sure exactly which one is the best at this point.
So do you think, let me ask you a follow-up question then, Scott. Do you think anyone that can go to a week 0 event is it's beneficial for them to do that?
Oh, for our team, that's a must. That's on the calendar. That is not optional. That is just as much a part of our routine as going to the competition. There are numerous week 0 events. You have to go. I mean, you have to go. That's all I can say, I guess. Too much to learn that weekend.
All right, Mr. Spees, what have you learned since kickoff to now?
I think in terms of the game, I think the biggest thing that I've learned so far is from watching a lot of video of a lot of different robots and different designs is that switch. A lot of teams are going to be able to do the switch. There's going to be a fight for the switch all the time. There's going to be a need for teams to, you're going to need a robot on your team that can really score in the switch quickly. If you can score in that switch very quickly, and allow your alliance partners to do other things on the field, and you can keep that switch on the entire match, I think you're going to be a very valuable robot. So there are going to be teams that are going to be able to go to the scale. There's going to be matches that there's only going to be one robot on the field that can do the scale. Beating that alliance is going to be hard. One thing that I guess I would note is, make sure that your robot's stout. There could be matches. If you are going to be the only one on the match that can scale, they're going to come after you. If I were alliance, I would go after that person. Make sure that they could not get that bin on the scale. So,
John, do you agree with what Andrew said? Do you think that there's going to be a lot of defensive play in this year's game? Robots that are really tall that people know can scale?
Yeah, I think there'll be some choke points that people can try to take advantage of, but they got to be careful because of the whole null zone thing, right? Like you can't contact a robot in their enemy null zone. So for us, our thing is stability. We want it to be a short, small robot that can score in the scale. So we obtain a cube and we get back to our null zone as quick as possible, and we do it as stable as possible, because you can be the best defensive bot in the world, but if you're tall or slow or anything like that, if you have any kind of weakness, then it's hard to kind of chase that person down and get to them. So one of the big things too is like when it comes to bot, attacking another bot, playing that defense is bumper height, right? So like we're trying to get our bumper as low as possible so that way nobody can get up under us and like push us and when we get into those pushing matches. So that's just one of those things where I think there's a potential, like a lot of potential for it. But as long as you're playing smart and you're going to the places that you need to go and, minimizing the possibilities of being able to get pinned, right? Not making runs to places you don't need to make them to, then you have a better chance of being dependent on less, hopefully.
Jeremy, are you setting your bumpers similar to the way John is, pretty close to the ground so you can't get upended?
Yeah, we haven't really looked too much into them. We just started to kind of figure that out. And I think with having the platform issues that we might have to relook at that. But I mean, it's just like football, right? The lower man under the pads usually wins.
Scott, do you agree? Do you have something similar or different to say when it comes to defensive play?
Well, I got to refer back again to our very first year. We had a very tall, very skinny robot, and we actually had one of our own alliance partners get under our bumpers and flip us, which, it puts you out of a running. So, yeah, you definitely have to be mindful of what's going on with the bumpers and the abilities of the other robots, especially with these ones that are probably going to be driving around with a scoop-shaped front that can pick up blocks off the floor or something like that. But yeah, definitely.
So what about a bot? What if a bot was tall but it's wide? Like I've seen some of the robot in 3 days, like they're called the greenhorns. I watched that video and their robot was really tall, but it was very much center. The center of gravity is right in the center where it was top heavy. What if
if you're driving forward and back and it's a short robot but wide and very tall, it's going to be very tippy. If you take off fast, it's going to want to tip back. If you slam on the brakes, it's going to tip forward. If you do a couple oscillations like that right in a row, you can dump it real quick. So it's going to be a lot on the driver. For stability, if you're just driving a normal kit parts base for stability, I would say a long robot would be better, especially if you're going for height. You're not going to be able to go around a corner as quick to dump it over sideways, but you can definitely incur some oscillation tip over just from having a short wheelbase.
Yeah, if you're a wide bot, you have a lot of potential of being a wide and a long bot because you're going to be on your back. So
yes.
Wow. So last year we worried about robots falling, right, with the rope challenge at the end, and I think we're going to see a lot of tip overs this year. So
yeah,
we're worried about them falling again. Yes.
So if anyone's building a
just
tall
in a different way,
make sure your weight distribution's even, so you're not one-sided or the other-sided. Or
there again, you've got no matter where you put the weight on the robot and centered in the robot is going to be better. But if you have it tall, your center of gravity is going to be high. And so if you, like I said, if you take off fast and then stop fast, and when you're playing defense, that's going to happen. It's going to happen on the field. So you just got to be concerned about your driver getting enough time to practice that kind of situation and know what's going to happen.
Andrew, tell us, give us some feedback on the height issue. Do you think it's going to be a huge issue with bots this year, or do you think worrying too much?
It's always really exciting. I think the most exciting part of a match is when a robot tips over and it can right itself. So I'm always looking forward to that match where the robot rights itself and everyone cheers from the stands, and it's always really exciting. So yes, watch your center of gravity. I think you will see some mechanisms that are pretty solid with their lifts, so that when they are going up, they won't be too bad. But there is an opportunity for a lot of center of gravity work this year, with the only time you ever have to get up on that platform is at the end of the game. So generally, I mean, there's other reasons, but generally at the end of the game. Now, one thing to note too is that platform isn't very big, right? So having 3 robots fit across that platform, not a lot of room to go. That being said, driving you can at that platform and trying to get up there because you don't have enough clearance could be detrimental to your alliance partners, or could throw you backwards and tip you over as well. So something to kind of take into consideration too, that there's not a lot of space up there.
All good pieces of advice. So I want to thank you guys for coming out tonight and coming on the podcast. We're all tired. We're now through 3 weeks of the build season, right? 3 more to go, and then we got to get ready to start playing. So as you sign out, please tell us how we can follow your team. And we're going to start with you, John.
Yeah, you can follow us at on Facebook. It's at F.I.R.S.T. Twitter, Chimera1684, Instagram, Chimera1684, YouTube, which is also where I post my vlogs, is the Chimeras FRC Team 1684. And then also our website at www.first1684.com. So lots of 1684s.
And Jeremy, how can we follow the Hollywood group?
Currently we're working on all of our multimedia, but if you want to reach out to me, it's at Coach Callahan 7211@gmail.com, and we're working on that.
Scott, how can we follow the Fridge Bots?
We are on Facebook at facebook.com/group/robotics5084. We are on Instagram as FridgeBot. We are on Twitter as Shio Robots, SHIAROBOTS, and we have a couple other informational pages around Facebook, such as sharing parts and whatnot, and events and training. I do want to mention that we have a question and answer thing coming up on Tuesday night. I don't know what time you.
Tuesday.
It's going to go out Tuesday. So if you hear this and you have questions about LabVIEW, drive to Vernon as quick as possible. We're probably sitting there.
Don't get a ticket. Come on, guys.
Don't drive like Andrew.
And Andrew, tell us how we can follow your team.
You can follow us at fenrobotics5114.com. Obviously, all the social media channels we're on. You can follow me at Andrew Spies on Twitter, or on Facebook, either way. Or, feel free to head over to the First Mentor Facebook group. Lots of good information going out there, asking about, sometimes we post stuff about, how to engage students, getting advice from other mentors on how to include students more, how to work with students. It's a big task to work with these awesome kids, and not everyone in First goes through any kind of training to do so. So having some feedback and getting some ideas on how to best work with kids, I think, is an extremely important thing for First. So
up now is the RoboZone Rookie Rundown.
With me, I have the infamous Brandi Bolinger, and we have another episode or another segment of Rookie Roundup. How you doing, Brandi?
I'm doing great. How are you doing tonight, Pete?
Good. How's your team doing? You guys in deep as far as getting your design done and everything going on?
Yep. As you know, every Monday night on our team is design review night. So tonight is the big night where we're starting to marry all of our subsystems together and move toward production on a lot of things that have been prototypes. So it's definitely been a busy weekend at the Nerds.
Nice. Busy's always good. I mean, overly busy isn't, but busy's good. So
yeah,
strengthening the minds of those young adults. It's always good.
That's the goal.
Keeps them busy and out of trouble. So we're going to follow the same format we did last week. We're going to do 5 things from last week, and then the 3 things that rookie team should be doing this week, right?
Yep. You got it.
So let's focus on last week. What is number 1 on your list?
All right. So by now, coming up to this point in time, you should have a moving, wired driving program chassis and have tested it going up onto the platform. So we had a couple of different rookie teams come and visit us this weekend, and actually a couple of veteran teams come and visit us this weekend, and they have started building their chassis. They've got all their components wired. They've got their motors mounted, and their robot couldn't drive up the platform. So then they had to take everything apart and redo it. So before you start permanently mounting things, make sure that your robot can drive up the platform. If you can gain access to a field where it's not just the plywood version, but the HDPE, the high density polyethylene plastic stuff that the real field is going to be made out of, try to drive it up that, because your friction, your rubbing, all of those kind of things are going to be a little bit different. So make sure that you're working on that.
So 2 things I have for you on that one, Brandi. If you're using the kit of parts chassis and you haven't made any alterations to that, you should be good to go, right?
You should be good to go as long as you did not mount your control systems and the churros on the lowest point. If the churros, the support bars that go all the way across the kit of parts chassis, are on the lowest point, you will definitely have a problem.
Okay. That's a good point for everyone that's a rookie team listening that followed the instructions for the kit of parts chassis. So you may need to move those churros.
Yep, you may need to.
Okay, what's number 2 on your list?
Number 2 is kind of a twofold thing. If you're working on any kind of manipulator, whether you're going to be just scooting the cubes across the floor, or you're going to be scoring into the scale, you're going to be scoring into the switch, start testing whatever you have built, whether it's your prototype or if you've moved toward a machined version, which is something that you should probably have as one of your stretch goals this week. Make sure that you're doing testing, but also recording the results. See how many times it takes you to pick up the cube. See how many times you drop it and the amount of distance that you have to go. See how many times it takes you to score it into whatever scoring part of the field that you're scoring it into. Write down those tests so that you can see as you make improvements and iterations where you start to see improvement and how you start to see improvement. With this, you can set a goal. So you might be able to say, if you're going to be, say, a vault bot, that you want to be able to score those 9 cubes in a certain amount of time. So if you're keeping track of how long each individual cube gives you, you can then give yourself a goal and try to reduce your time. Same thing if you're going to be scoring into the switch or into the scale. If you have a goal of a certain number of cubes per match, then your test results and comparative analysis will allow you to improve your test times.
Okay. And number 3.
This one is kind of something that's going to start now and maybe keep going for a couple of weeks, depending on how your team works, is to begin looking at a drive team. So you're going to have a drive coach on your team. On the Engine Nerds, it's Clinton. We choose to have an adult go to the field because we feel that it's beneficial for a person who has been involved with F.I.R.S.T and a person with an adult's kind of level of experience and analysis go onto the field. And also to help, mentor on and off the field. But that mentor should probably be looking at the 2 students, a driver and an operator for the robot, a human player, and the technician. There are 4 members of the drive team this year. So begin looking when you are testing your chassis, who's driving it well, who's doing things like that. But the most important thing that you need to look for in your drive team is leadership. Someone who's a fast, independent thinker, someone who can make decisions that are good for the team when you're not there. You can teach anybody how to drive a robot. You can't necessarily teach everyone to be a leader.
Okay, I do have a question for you, Brandi. I thought there were 5 people on the drive team this year.
One of them is the drive coach.
Okay, perfect. So I always include the drive coach in that 5. So yep, we're both
choose
talking.
a student.
Yeah.
Yeah, you can choose a student. Some teams do. I would recommend, especially for first-year teams, to put an adult out there, just because there are a lot of veteran teams in this organization who do have a lot of experience. And for a student to go out to the field as a drive coach, that's a lot of weight on their shoulders for their first year on the team, right? And while they may be really great leaders, there's nothing, I guess, wrong with sending a student, but you just will have another battle to overcome when you first walk out onto the field.
Makes total sense. So what is number 4, Brandi?
Start your cost accounting worksheet, or your CAW. So first on the resource page has a cost accounting worksheet template for this year's game that they just released a little bit ago. And basically what the cost accounting worksheet is an Excel spreadsheet that keeps track of the costs of the items for your robot, because each team does have a $4,000 budget. However, you get a kind of a good deal because anything that you get in your kit of parts, you don't have to count in anything that you get from First Choice. You do not have to count the funds toward that, but they do want you keeping track of the number of components that you have on your team, on your robot, and how many of those things you have on there. So you still do have to list things like your power distribution board, your Robo Rio, your voltage regulator module, your any speed controllers that you got in your kit of parts, but you don't have to count the cost on those. But then anything that you add, you also have to put on there. So say you're building some kind of an intake and you used some roller wheels and some aluminum and some belts and a motor. You do have to continue to use those things on there. There is a section in the manual that explains how to do your cost accounting worksheet. It's just our advice to you to get out ahead of this now so that come bag day, you're not counting how many inches of aluminum you have. Start counting it as you're putting it on.
So I have a follow-up with this too. So last night I was using my 3D printer in my home, and I printed out some hex pulleys that I'm going to use for a conveyor system on my robot. How do you account for those customized parts where I made it, you know?
So you don't have to count the labor, especially if it is donated to your team. However, you did have to pay to have it made, then you do have to count that labor. But if you are, so I'm assuming that you're going to donate the time that you spent making that to your team.
Yes, ma'am.
Yes. So if you have a partner, say, who machined something for you, or a sponsor of your team who gave you something, you only have to count the value of the object. So however much the material cost you to make that at your best estimation.
Okay, perfect. And finally, number 5 for last week.
So you're going to want to go on to firstinmichigan.org and start looking at your event info. Coming up here over the next couple of weeks, our follow-up for next week is that you're going to start applying for field trip days and those kind of things, creating agendas for the competitions. And you can't do that unless you have your event info. On the First in Michigan page, if you go to firstinmichigan.org and click on FRC events in 2018 season, all of the districts and the state championship and the world championship actually are all listed on this website. Most of them do have event agendas up there. So just start the conversation with your school and your students about the expectations of when you are going to want to be there. And you are definitely going to want to be there the whole time. So we understand that some teams are traveling a little further to get to their district events, and they might not be able to be there right when the doors open, but do try to get there as quickly after that as possible.
And for those teams that aren't in Michigan, they of course can go out to the Blue Alliance and get information for their events.
Absolutely. Yep.
Perfect. So thanks for giving us the 5 for last week. So let's switch gears and let's talk about the upcoming week. Tonight's Monday night when we're recording this. So what are the 3 things that rookie teams should be focusing on at the beginning of this week?
So especially if you are not working with a school, and you're not familiar with their field trip policies and attendance policies, you're going to want to start looking into field trip days for your students. I know at our school, at Grand Blanc High School, all of our students, when we go to competition, as long as they've met our GPA requirement and our school assignment requirement on our team, then they get a field trip day. So we have to go in front of our Board of Education 30 days in advance and ask for those field trip days. So that may be something that you need to start looking into for your team. If it's an overnight, if you are traveling to a regional or a district where you're going to be staying overnight in a hotel, do you need to get special permission for that? So there is sometimes about a 30-day lead time on some of these things. So start familiarizing yourself with the policies and starting that conversation with your school's administrators.
Perfect. That was number 1. So what's number 2?
Number 2, build your bumpers. So last week you should have gotten your bumper material on hand, or it should be on the way to you. So as we talked about earlier with your testing and recording of your results and your moving driving chassis, you're going to want to have a set of bumpers on that robot for all of your testing, because the way that the robot goes up over the platform with and without bumpers is totally different. So make sure that you have your bumpers on hand and that you've read the bumper section of the manual. Some teams choose, I think, Pete, you guys are choosing to do the reversible bumpers, right? Where you build one set and just the fabric flips up or down.
Yes, ma'am, from Robo Promo. They're not a sponsor, but they do an outstanding job. So
yes, they do. So you can go on there. If you are a rookie team, you do get a $36 discount on your order, which is super awesome. So have your bumpers ready and built. Mike at Robo Promo will even put your bumper numbers on for you to make it a lot easier for you to build your bumpers. So get that going.
And make sure that if, like, for my team, we have a cutaway on the front of our robot, so make sure that you're sticking to that 6 to 8 inch bumper requirement on the front.
Read the bumper rules. Number one reason that teams do not pass inspection at their first event is bumpers. Don't be that guy.
Yeah, I don't want to be that guy.
Yeah.
I already ordered my stuff, so I'm good. Okay, finally, number 3, Brandi, for this week.
One thing that our team does is, starting at this time when it starts to be crunch time, we start a countdown to build day, and we create goals for ourselves. So we look at what we've accomplished and what we still yet have to do based on our Strategy Dictates design method. We keep all of our priorities up on Post-it notes in our conference room where our team meets, so that everybody sees it every single day, so that they understand that something lower on our priority list should not be affecting something that's higher on our priority list. So we always, about this time of day, start talking about how many days left we have of build and how many hours of machining we have left to do, or how many hours worth of assembly we want, or how many hours worth of practice we want to do, and try to work that into our schedule. We sometimes even take and print off the numbers like a calendar, like you rip off, and put it up so that everybody realizes exactly how many days it is till bag day, which this year is February 20th at 11:59 p.m.
Right, and do you guys do like a project or a burn down chart? I know I'm using Agile software development methodology, but do you guys? It sounds like you guys are following something like it. So
we try to do a little bit more of a flexible schedule, just because we do a weird combination of outsourcing and in-house machining. So some of our things go off to water jet, some of our things go off to powder coating, some of our things are machined in-house, and some of our things are COTS items. So the fact that Vex and Andy Mark are both running out of a lot of things very quickly has definitely changed our timeline a little bit, as some of the things that we were intending to order, we now get to make. So, which is great for our students because they're getting experiences on the lathe and the mill. However, it adds time to our machining and fabrication process. So we do our best to kind of have weekly goals similar to what we're talking about here for the first year teams, instead of daily goals of when things are due.
It's getting busy.
We're entering week 4 now. We've only got about 2 weeks left. We're down to crunch.
It's getting nuts. It's 3 weeks from Wednesday, right?
You got it.
Yeah, and it's by noon, so you really want to kind of be wrapped up the day before. I don't know how many
you
people
get till
are taking
midnight.
the day off.
It's 11:59 p.m. So you get till Tuesday night at 1 minute before midnight.
Oh, okay, perfect. Thank you for.
So you still get Tuesday night. Yep. Our team uses Tuesday night. We actually host what we call our partner showcase, where we invite all of our sponsors of our team to come to Premier Tooling Systems, where we build, and we have our parents make little fancy hors d'oeuvres, and our students give a full season design review of the design process of our team and robot, and our partners get the first reveal of our robot.
Awesome.
So that'll be happening on
It's not a webcast or anything, or on Twitch or something like that, is it?
Last year it was. This year I don't know if it will be. We were featured on the Robo Sports Network's check-in last year, so I don't know if we'll be doing a live reveal or not this year. We've not decided.
Are you doing a reveal video?
We usually don't.
I'm trying to mount some more stuff for you to do, Brandi, as if you didn't have enough.
Right. Our first event is week 2. So, and we'll be, week 1, we'll actually be setting up the Kettering 1 district, as we're in charge of the field setup for that. So we've got a full plate.
Yeah. Okay. No reveal video. That's fine. I'll see it for myself at Kettering week 2, right? Kettering week 2 you're going to.
We'll be at St. Joe's week 2.
Or, sorry, St. Joe's.
Yep.
Yes. All right, Brandi, I'm not going to take up too much more of your time. Thank you for stopping by. We're going to do this the same bat station, same bat channel, same bat time next week. So we'll talk to you next week.
All right, Pete. Take care.
Up next is the RoboZone Team of the Week.
The team of the week for this week is Engine Nerds Team 2337 out of Grand Blanc, Michigan. Clayton and Brandi Bolinger do nothing but try to help as many rookie teams as possible. As a rookie mentor myself, they've helped me tremendously. They help their community, and we want to give them team of the week this week. So congratulations, Brandi, Clinton, and all the Engine Nerds out of 2337. You are our team of the week. Congratulations.
The RoboZone Podcast is brought to you by Kettering University. It's a Kettering-built world. Thanks for listening to the RoboZone Podcast with your host, Pete Ekman. Find us online at RoboZoneTV.com and on Facebook, Twitter, YouTube, and Instagram.